Welcome. This is the second video on solutions. Today we're going to talk about percent solutions, molality, very close to molarity, but molality, and mole fractions. So let's dive right in. Let me share my screen, and here we go. So, percent solutions can be done in three different ways. The first way, sorry, my computer is taking a little bit longer to get up, is by percent volumes. So that would be volume of solute divided by volume of the whole solution times 100. And when we do these solutions, we're going to keep them in milliliters. So pretty straightforward when we talk about percent. Remembering percent is means by 100, so we're going to times it by 100. We can also do a percent solution by mass, and that's where you can see the M divided by M. So here would be the mass of the solute again, divided by the mass of the solution times 100. And when we do mass, this will be in grams. The last type is when we kind of mix them together. We're going to do mass divided by volume. But let's do a practice problem first. This practice problem says, what is the concentration in percent of a solution containing 50 milliliters of diethyl ether in 2.5 liter solution? Now, it doesn't necessarily say what type of percent, but because they're both in a volume, let's make this easy and do percent volume of them. Now, remember, we're going to do this in milliliters. So the solute, which one's the solute? Well, remember, that's the one that's the smaller one, or if you can read into there, it talks about the one dissolving, but the easiest way, I think, is the smaller one. So we're going to take, and I'll write this one out, we're going to take the volume of the solute divided by the volume of the whole solution. And this problem's nice because it tells us the whole solution in there. And again, we want these in milliliters. So the first one is already in milliliters. That's 50 milliliters of the diethyl ether divided by the total solution. And you don't have to show this anymore. Hopefully, we know that that's moving the decimal place is 3, in this case to the right, times 100. And when I do this, I get this to be a 2% solution. And that is volume by volume. All right, let's move to another one. Here, it's asking for how many grams of potassium sulfate would we need to make this. And you can see that it gives us in grams. So this is our key here. Hey, it gives us in grams of a solution. So we are looking at a percent volume because it has a grams in mass versus mass. Oops, that's a V. Mass versus mass. So let's set this up. We know that we want the mass of the solute over the mass of the solution times 100. And that gives us our actual percent. In this question, it's asking for how much. So we're really looking for the mass of the solute. So we got to just change what we're looking for and finding the x. So I'm going to put everything in. We don't know the top number. That's our x. Divided by our whole solution, and it tells us that that is 1,500 grams times 100 will equal 5%. Now moving to our next step, I'm going to move this up. My next step, I'm moving this up here. If we divide both sides by 100, that gets rid of that times 100. We would have x equals 1,500, or x over 1,500 equals 0.05. Continuing with some algebra, we're going to times both sides by 1,500, and that's going to give us x equals, and when I got this, I got 75 grams. Now, we can always check if this is correct. We can put it into our calculator. So if I take 75, because that's what we found, that's where that x is, divided by 1,500, times by 100, we should get 5%. And I don't know if you can see my calculator, but that's what we got there. Now, here's our combo one. This says, what is the percent by mass over volume? So just like what it says, mass over volume. And the big key here, we have to remember when we do this, this is grams over milliliters. So this one looks pretty straightforward. We have our mass, which is 16 grams, divided by our volume of the solution. And this one's already in milliliters, so that one's good for us. So this would be 400 times 100. That's the percent part. And when we do that calculation, I'll double check. I think I got 4%. And I do. I get 4% solution. So if I'm looking at these problems, the big thing is make sure that I'm in the correct units and what type of percent it's asking for. And remember, percent's always by 100. So that's our percent solution problems and equations. Let's move on to our next concept of molality. Now, you just got done learning about molarity, which is big M, which is moles over liters. And that's a way of talking about concentration. How much stuff is in that solution? How much sugar is in your Kool-Aid? Well, this is another way of talking about concentrations. And we give it the small m abbreviation or symbol. And some people will even do it at like a little italic small m. But this is moles of solute over kilograms of solvent. So very similar. The only difference here is it's the kilograms of solvent. So just remember your units. That equation is important. And it is independent of temperature. So we won't really even change temperature or do anything, but just in your notes as you go further in chemistry, independent of temperature. All right, let's hit a couple. So here it asks, how many grams of sodium fluoride are needed to prepare a 0.400 small m sodium fluoride solution that contains 750 grams of water? There are many ways to set this up. It's really dimensional analysis, understanding that that M is molality. I'm going to start with that. So I'm going to write this down, 0.400, and I'm not going to just put the small m. I'm actually going to write out what it is, and that is moles over kilograms. Now, most of the time our kilograms are in our water. That's our solution. Now, it's asking for grams of sodium fluoride. That is our solute. So that's that top number of moles. But we got to change moles to grams and cancel out kilograms. So let's do that. Dimensional analysis. I'm going to first cancel out the kilograms of solution because we have 750 grams of water. We are going to change grams to kilograms, moving the decimal place 3 times. If we stopped right here, we would be in moles. The question asks for grams. So one last conversion, we're going to do 1 mole equals the molar mass. And when I did this, I got 41.99 grams. And notice our moles will cancel with moles. We're left with grams of what we're talking about. I'll quickly talk about this empty area here. Some people, that bothers them. You can put a 1 here if you want, but there's no unit for it. So it still cancel out. So when I'm all done, I get an answer. I'm going to put it on the bottom. I got 12.60 grams, and this is of our sodium fluoride. So when you think about these problems, if you're into that dimensional analysis, there's really only a small new unit that we've given you, and that's moles over kilograms. So there'll be different questions that we can ask for. So there's one type of question where it asks to find how many grams of it. So the top number. All right. Let's look at another problem. It says calculate molality of a solution prepared by dissolving 10 grams of sodium chloride in 600 grams of water. Our big key here is units, units, units. Molality, or small m, is moles of the solute, or the small stuff, divided by kilograms of the solution, or solvent. Now, here we just got to make sure we're in the correct units. Our solute is 10 grams of sodium chloride, so we got to take our 10 grams and change that to moles, and we can do that by dividing by the molar mass. And the molar mass of this I've got to be 58.44 grams times 1 mole. And my answer, I get 0.17 moles of sodium chloride. So that gives us the top number. Now the bottom number, I really don't think we need to do any math. We just have to remember that we can move the decimal 3 spots to the left to get kilograms. So let's just fill that in. We have 0.17 moles divided by 0.600 kilograms. And my final answer, when I do this, is 0.28. And now this is small m, and I kind of italicized that, of that solution. So again, just very similar to molarity, but molality. So really got to look what the question asks for in there. Those words are very, very similar, so be careful when you do problems. All right, our last concept of the day, mole fraction. And a lot of these are mole or something over the total, and it's the same thing here. Moles of what you're looking at over the total moles of solution. The key word in this is moles. So if it gives it to you in grams or liters or whatever it gives it to you, convert them to moles. So X can be used for this fraction. And again, I'm going to go through some problems and show you how to do them. Probably important on this is that the units cancel out, so there are no units. When you add all these together, they should equal to 1. So let's look at them. This one says, what's the mole fraction of each component in a solution made by mixing 300 grams of ethanol and 500 grams of water? So first of all, we got to convert all of this to moles. So we need to take our 300 grams of ethanol, C2H6O, and convert it to moles. And I've got the molar mass of this to be 46.08 grams per 1 mole. Hurrying through my math a little bit, I get 6.51 moles. So that's part of it. We got to look at the other part. How many moles of water is this? So water is H2O. Again, we're going to divide by the molar mass, which is 18 for 1 mole. And when I do this, I get, rounding a little bit, 27.78 moles. So if we add these two together, that will be our total moles. So I add those together and I got 34.29. That's our total moles. So what's our mole fraction? Mole fraction of the ethanol is 6.51 over our total, which is 34.29. Now it says each component, so let's talk about water. And we know that water, 27.78 moles over our total, which is 34.29. So that's just our mole fraction. Really, we've done these a lot, percents and stuff and what we want to. So there's that one. Now, to save time a little bit, because I have one more problem for you or in your notes, what I'm going to do here is stop just for a second, or you should pause the video, and I'm going to give you the answers I would get for it. So pause the video quick. Welcome back. What you should get for carbon tetrachloride is, let me get my pen out, sorry, is 0.33 over 0.81. And the other one is 0.48 divided by 0.81. All right, thank you for paying attention. We'll be back to look at some of those homework questions if you have them. Have a good one. We'll see you later.